23.262. Good. 23.262. Multiply by 8.154. We take 8.154 because it's the position at point A. And we know it's tensile, that's why plus. And then we divide by 3.88 times 10 to the power minus 9. Okay. So this is equal to 400 divided by 104 power minus 6. Okay. No, 400 divided by 104 power minus 6. So this is equal to 3.846 times 10 to the power of 6 plus by 23.262 times by 8.154 power minus 3 divided by 3.88 power minus 9 is equal to 48.886. Okay. Times 10 to the power 6. Let me do it again. So 23.262 times 8.154 power minus 3 divided by 3.88 power minus 9. 48.886. So the stress is 3.846 power 6 plus 48.886 power 6 is equal to 52.732. Positive 52.732 times 10 to the power 6 Pascal. Okay. Then we're going to find stress X at point D. Okay, so this is where we have Px over A. So we know at point D, right, the bending's in what? The bending is in compression, right? So we put a minus mz over izz multiplied by y. So Px over A is the same. So you can put 3.846 times 10 to the power 6. Now the moment is different now. It's 23.262. Now the distance changes. Because we are looking at point D, the distance is what? 11.846, right? So 11.846. Oh, this one should be minus because it's compression. 11.846. And then divide by 3.88 times 10 to the power minus 9. Okay. So this is equal to 3.846 times 10 to the power 6 minus by 3.262 times 11.846 power minus 3 divided by 3.88 power minus 9 is 71.021. Times 10 to the power 6. So this is equal to 3.846 power 6 minus by 71.021 power 6 is equal to minus 67.175 times 10 to the power 6 Pascal. Okay. Now the next part of the question, right? But one thing I want you to observe is this, okay? The stress induced by bending is much higher, right? Much higher than the axial loading, right? The bending stress is much higher. So that's why if you want to break something, right? You want to break a ruler, you start pulling, it don't pull. What is our natural tendency? Anyone? What's our natural tendency? We tend to what? We tend to bend it. Okay. So when we bend it, it's because we increase the what? The stresses. You all realize that, right? When we bend it, we increase the stresses. And the more you bend, right, the stresses get higher. Okay. Because the more you bend, the forces are higher. The forces are higher. The moment are higher. That's why you break your ruler easily, rather than what? Stretch. It's so difficult to break ruler doing stretching. Okay. Right. So now what we see is we have a tensile and then we have a compression. So the next question asks, locate the position of the neutral axis. Okay. So we're going to do the position of the neutral axis. Okay. So if we were to look at the formula, okay, if we're going to apply the formula, we have stress X is equal to Px over A. And in the rightful form of the formula, this is equal to minus, okay, mz over izz multiplied by y. Okay. So I'm going to show you two ways. I'm going to show you applying the formula and then ignoring the formula. Apply something very simple, like in your first in your grade 10 math or grade 11 math. Okay, but I'm going to show you by using the formula. Okay, so you know at the neutral axis, right? We know at the neutral axis, right? Stress x is equal to 0. So I call this equation. So therefore, equation 1 becomes, okay, so this is 0 is equal to px over a minus by mz over izz multiplied by y. Okay, so px over a is equal to mz over izz multiplied by y. Okay, so now after this, we know px over a is equal to what? 3.846. Okay, so 3.846, right, times 10 to the power 6. And our mz is equal to 23.262. Okay, so our mz, if we look at our moment, okay, our moment is going in a, if we look at our moment, okay, so if we look at our moment, okay, is at what? Is going at 23.262, and then our izz is equal to 3.88 times 10 to the power minus 9, and then with a y. Okay, so the y over here will be equal to 3.846 times 10 to the power 6 multiplied by 23.262, and then we're going to divide by, no, what am I doing? This is 3.888 times 10 to the power minus 9 divided by 23.262. Okay, so our y, 3.846 power 6. Okay, so we get 3.846 power 6 times by 3.88 power minus 9 divided by 23.262. You get 0.641, okay, times 10 to the power minus 3 meters. So it's positive, it's moving downwards. Why downwards? Remember I told you the first week, right? So if our bending is this way, over here, this is a center of curvature, right? And then going this way is your y what? Positive. Okay, so this is just purely applying the formula. But what if you forget the formula? Yeah, what if you forget? So it's also very straightforward. As I said, you can use your high school math to do this. Okay, so because you know your position of your stresses. Okay, so we're going to sketch this. Okay, so I'm going to sketch our stress x. Okay, so I want to see I have enough position. This is just a sketch, okay? Wait, 2, 4, 6, 8, 10. Yeah, I think I have enough. Okay. Maybe I will have enough for the full thing. Okay, so we sketch, so we have minus 80, minus 60, minus 40, 20, 0, 20, 40, 60. Okay. Then we have our, so this is our normal stress in X. Then we have our Y. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just not enough. 1, 2, 3, 4, 5, 6, 7. Okay, not enough. It's okay. So this is my 2, 4, 6, 8, 10, minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. Okay. Then we know that when it is, so this is our y, right? So we know that when it's our 8.154, right? So 8.15. So basically anything up here is our y positive. Anything that is below is our y what? Negative. Okay. So we have 8.154. We get 57. Okay, so 50, 57. I'm just going to eyeball this. It's somewhere around here. Okay, somewhere around here. So that is our 50. No, 57 should be more on this side. Okay, so this is our. So you have to label this. Okay, so this is our 50. Not 57. It's 52. Eugene, come on. So 52. 8.154. Okay, so this is our 52.732 and 8.154. Then our next one is at what? 11.846. So 11.846 and it's at minus 67. So 65, 67, 11.846. So 11.846. So I'm going to eyeball this. So this is our 11.846. Yeah, 11.846 and 67. Okay, so 11.846. So 67 minus 67.175. And then we have our 11.846. Yeah. So now we draw a line. Yeah, we draw. So you can see that there's a shift. Okay. You can see there's a shift downwards, like what the normal calculations show us, right? Down here you can visualize better. I always like to use this. Okay, so you see a shift down here. You can see there'll be a shift, right? You can see there's a shift down here. Okay, so we know that this is a linear function, right? So we are going to do the math now. Okay, we're going to do the math now. So the math we're going to use is equal to y is equal to gradient stress x plus c. It's a simple equation. Okay, what we want to find is we're going to find c, which is the y-intercept. Okay, so the y-intercept, what it gets us is this. Okay, so this is very easy math that you can see. So the gradient m, first you have to find the gradient m, which is change in y divided by change in x. Okay, so change in y. Okay, so if we look at change in y, we're going to take the whole thing. Okay, we're going to take the whole thing. So the change in y is what? Is if I do it in meters, so the whole height is 20 millimeters. Okay, so 20 milli 20, so 0.02. The change in x will be 57.52. Okay, 52.732 times 10 to the power 6 plus by 67.175 times 10 to the power 6. Okay, so this will be equal to 52.732. So 52.732 power 6 plus by 67.175 power 6. So 0.02 divided by this. So it's equal to 166 0.796 times 10 to power of minus 12. Okay, and I just want to write the units